Welcome back to 3D GBIRE. Today we're having a look at a brand new material straight out of BASF, which is called PLA Tough. This is an enhanced PLA giving you better strength and heat properties when it's annealed. This means you can develop your 3D printing capabilities and advance what you can do with your standard 3D printer. Let's have a look at the material.
Because PLA is such a widely used material across a lot of different areas of additive, it makes sense for us to look at how we can advance that, and BASF have done exactly that. With the PLA Tough line, it not only is 7 times faster than standard PLA, it's 7 times stronger. It's also competed with the likes of ABS in terms of the heat properties as well as the strength properties. Now with PLA Tough it's completely post-processable, so what that means is that we can do machining, we can also do a annealing process, which means that we can get 157-degree temperature resistance through this PLA right here. So you not only get ease of the print, but you also get massively enhanced mechanical properties. The really exciting thing with PLA Tough is the applications that we can produce with this material. It saves us the need for going for those difficult to print materials like ABS, polycarbonate, and even nylon with its moisture absorption properties. One of the really powerful applications that PLA Tough has managed to enable for us is this pneumatic regulator mounting bracket. Traditionally this would be produced in about 14-15 hours with standard PLA. Now because of the speed enhancements that we get with Tough PLA, this has actually been produced in just under 4 hours. So not only has it managed to keep the machine operational, but it's managed to save any extra downtime by just being able to be printed so much faster. One of the other properties about PLA Tough is it has biocompatibility certification. Direct from BASF, documents are already available for you to download. But what this also allows us to do is to produce really tough applications. In this case, we've got like a casting housing, which will go over a patient's arm. This can be produced on any FDM machine, so it doesn't have to be any kind of particular expensive equipment, nice off-the-shelf products, and again, you can produce these in-house at rapid print times with 7 times faster print speeds. The final benefit we have with PLA Tough is the opportunity to anneal these parts. What that can do for us is give us better heat properties. So with products like this, where we can go into secondary processes such as vacuum forming, pressure forming, potentially even machining, and we have more resistance to pressure, to heat, anything that's going to be going on underneath those conditions, it means that we can again work with these standard materials, easy to print, but get really enhanced properties. The final ace that PLA Tough has up its sleeve is the ability to be annealed. What that can do is give us better mechanical properties and also better temperature resistant properties as well, giving us a resistance of up to 157 degrees and allows us to go into the likes of forming properties and using additive as a segue into different manufacturing processes.
If you want to know more about the PLA Tough from BASF or get a few reels yourself, go to 3dgbire.com and the team will be happy to help you out.